Hello viewers, I'm Kausalya. Today we are going to solve problem 4 related with hybrid parameters. So the problem is obtain the hybrid parameters for the network shown in figure. So this is the given network. So we start with writing the basic equations. So these are the basic equations. V1 is equal to H11I1 plus H12V2 and here I2 is equal to H21I1 plus H22V2. So here as a first step we are making V2 as 0 and we are going to calculate H11 and H21 terms. So how can you make this V2 0? As we all know, again I am repeating, V1 is the input voltage and V2 is the output voltage, and here I1 is the input port current and I2 is the output port current. So here now we are going to short circuit this output port, thereby making the value of V2 as 0. So just I am redrawing the same circuit by short circuiting the output port. So here we have just short circuited, thereby V2 is 0 and I1 is the current flowing through this path. Okay, now you don't think about this I2 dash. Okay, this is for finding the H21 value. So the first thing is the value of V1 is equal to H11 I1 when you make V2 as 0. So H11 is given by V1 by I1. So now we are going to calculate V1. So here V1 is given by I1 into Z, that is the total impedance. So when you look at the direction of current, you see this current I1, when it reaches this node, it gets divided into 2. Again here when it reaches this node, it again gets divided into 2. So when the current gets divided, what does it mean? The two resistors are parallelly connected. So here you see these two resistors are parallelly connected. So what will be the equivalent resistance? So it is 2 into 1 divided by 2 plus 1. And this combination comes in series with this 2 ohm. So when two resistors are series, we will simply add. So here that is 2 plus this combination of resistances. And again this entire combination is in parallel with this 1 ohm. So 1 parallel with this thing. And finally this entire combination is in series with this 2 ohm. So here it is 2 plus. Okay, am I making things clear? That is, you see the current at this node divides into 2. Again this current, when it reaches this node, it gets divided into 2. So whenever the current gets divided, what does it mean? The resistors are parallelly connected. So here when you find the equivalent resistance for this combination, that resistance is in series with this 2 ohm. Can you imagine? Right. When I find equivalent resistance of these two resistors, then you will be having a single value of resistance. Then these two resistances are series, that is connected in series. And how the circuit reduces? Your circuit will reduce like this. So when these two resistors are combined as one, here we will be having this resistor. So now at this node, what happens again? These two resistors are parallelly connected. So when you combine these two resistors, obviously we will be ending up with these two resistors. Finally, these two are connected in series. Okay, this is what I had written here. You see, here these two resistors are connected in parallel. So this is your equivalent resistance. And that combination is in series with this 2 ohm. So 2 plus. And again this entire combination, okay. And again this combination, that is this combination is in parallel with this resistor, therefore 1 parallel. Okay, this is 1 ohm. And finally the entire combination, that is when these two are solved, then this combination is in series with this first resistor, that is 2 ohm. So this is what I had written here. So we have to solve. So 2 into 1 divided by 2 plus 1 gives you 2 by 3. 2 plus 2 by 3 is nothing but when you take LCM, 3 2s are 6 and 6 plus 2 is 8. So it is 8 by 3. Now 1 is parallel with this 8 by 3. So how to write? 1 into 8 by 3 divided by 1 plus 8 by 3. So again when you solve, here when you take LCM, 1 into 3 is 3. So 3 plus 8 is 11. So here 8 by 3 and here 11 by 3. So 3 and 3 get cancelled. And finally here we have 2 plus 8 by 11. So again when you take LCM, so here it will be 2 into 11 is 22. So 22 plus 8 by 11, which is 30 by 11. We have calculated the value of network impedance. Now we are going to substitute in the equation. So what is the equation here? You see V1 is given by I1 into Z. So V1 is equal to I1 into the value of Z is 30 by 11. Okay, even you can write it as ohm. So here, but what we actually need, we need the ratio of V1 by I1. So just rearrange it. So V1 by I1 is 30 by 11. This V1 by I1 is nothing but H11. So which is 30 by 11 ohm, because it is the ratio of voltage to current. Now we will proceed finding H21. So here H21 is nothing but it is the ratio of I2 by I1. So here we are going to calculate the value of I2 and we are going to substitute in this equation. So for that, here we are introducing a new term that is known as I2 dash. So just I had redrawn the circuit, you see. Here these two resistors I had drawn it as such, and I have solved these three resistor combination. That is, these two resistors are connected in parallel and that combination comes in series with this 2 ohm. Right. So here this is what we have done. These two resistors are parallel and that is in series with this 2. So you see it is 2 into 1. Okay. These two resistors, that is these two are in parallel, right? So 2 into 1 divided by 2 plus 1 and that comes in series with this 2. So here it is 2. So when you solve these things, here we are ending up with 8 by 3. Therefore, here I have drawn these two resistors as such and I have replaced these three resistors with its equivalent resistance value, which is 8 by 3. So here I have taken the current here as I2 dash. So now we are going to calculate this I2 dash. So here I2 dash is nothing but here the total current is I1. I1 into that is here we are applying current division rule. Okay. It is better to write because we don't know, okay, how we can written this. So by current division rule, I2 dash is equal to I1 total current into opposite resistance. So what is the resistance which is opposite to I2 dash here? It is 1 ohm. Okay, 1 divided by the total resistance. So here the total resistance covers this. So 1 plus 8 by 3. Right, because here we are considering I2 dash. So I2 dash is nothing but total current into opposite resistance divided by this total resistance. So when you simplify here, 1 plus 8 by 3 gives you 11 by 3 and I2 dash is nothing but I1 into 3 by 11. Now from this I2 dash we are going to find I2 because here we need the ratio of I2 by I1. So again I am drawing the original circuit here, right? This is I2 dash, that is I am replacing this 8 by 3 with its equivalent resistors, okay, 2, 1, 2. That is, this is the original circuit. Now this is the current I2. So here the direction of I2 dash and I2 are opposite to each other. Therefore here I2 is nothing but, okay, I2 is equal to, we need I2. So I2 is equal to, here the current is I2 dash. So they are opposite here. So here there is a minus sign. So I2 is equal to I2 dash into, what is the resistor which is opposite to I2? It is 1 divided by total resistance is this 1 plus 2 because this is the path where it travels. So I2 is equal to minus I2 dash into 1 by 1 plus 2. So again when you solve here we get 1 by 3 and what is I2 dash? I2 dash is nothing but I1 into 3 by 11. So just substitute the values. So write this minus sign here and I2 dash is I1 into 3 by 11 and here this 1 by 3. Now this 3 and 3 they get cancelled and here we have minus I1 by 11. But what we actually need, we need the ratio of I2 by I1. So when you rearrange this equation, that is, you see I2 is equal to minus I1 by 11. So now the ratio is just I2 by I1. I am moving this I1 to the left hand side, or else you can just substitute. Okay, here we are substituting, anyway it is fine. So I2 is equal to minus I1 by 11 divided by I1. This I1 get cancelled, and here we have minus 1 by 11. So therefore the value of H21 is minus 1 by 11. Now we are going to calculate the remaining two parameters. So for that, initially we have made the value of V2 as 0. So now we are going to make the value of I1 as 0 so that we can calculate H12 and H22. So how can you make the value of I1 0? Once you make this side open circuit, okay, when you make this input port as open circuit, then obviously I1 is equal to 0. So here you see we had made this port as open circuited, right? We had open circuit this side, input side, and this is how our circuit looks like. So here this is V2 and this is I2. Now the first step, we are going to calculate the value of H22. So H22 is nothing but it is the ratio of, H22 is nothing but it is I2 by V2. So now we are going to calculate the value of V2. So V2 is nothing but it is I2 into Z. So here we are going to calculate the value of impedance. So you see the current, when it enters at this node, it gets divided into 2. And again this current, when it reaches this node, what happens? Can you make a guess? Here we are having an open circuit path, and a current will never flow through an open circuit path. So what happens here? At this node, the current flowing through this 2 ohm flows through this 1 ohm. The current won't get divided at this node because here this side is open circuited. Always keep this in mind. So what will be the equivalent, that is what will be the value of impedances? So again here you see, here the current divides and here the same current flows here. So what does this means? That is these two resistors are connected in series because the current flows, okay, flowing through this ohm flows through this 1 ohm. So here these two are in series. So the equivalent resistance is 2 plus 1. And this combination is in parallel with this 1 ohm, right? Can you guess? You see, this is your 2 ohm and this is your, okay, this is your 2 and 1 here. Now these two are solved, okay? So 2 plus 1 gives you 3. Now what happens? Here these two are connected in parallel. So to this combination, okay, to this combination here, this 1 is in parallel. So 1 parallel with this 2 plus 1, and this entire combination is in series with this 2 ohm, because when you solve this, it will become a single resistor, and that resistor is in series with this 2 ohm. So this is what it is written here. Now when you solve, 2 plus 1 is 3 and 1 parallel with 3. So 1 parallel with 3 is 1 into 3 by 1 plus 3. So it is 3 by 4, and this comes in series with this 2. So 2 plus 3 by 4, when you take LCM, 4 2s are 8 and 8 plus 3 gives you 11. So it is 11 by 4. This is the value of your Z. Now substitute this in this equation, right? That is V2 is equal to I2 into Z. So I2 into the value of Z is 11 by 4. What you actually need? You need the ratio of I2 by V2. So when you bring this V2 here and when you move this term to this left hand side, they become 4 by 11. Okay, they will appear as reciprocal. So the ratio of I2 by V2 is 4 by 11 more, because it is the ratio between current to the voltage. Finally, we are going to find the value of H12, which is nothing but V1 by V2. So now we are going to calculate the current that flows through this 3 ohm by using the current division rule. Thereby we can easily calculate the value of V1, because here we need V1 by V2. So here V1 is, you see again the circuit is redrawn, right? This 2 and 1 I had kept as such. Again you see this circuit is just redrawn. You see here we have V2 and this 2 and 1 as such, and now these two are a seriously connected. Okay, they are connected in series. So 2 plus 1 gives you 3. So these two resistors are replaced by a 3 ohm resistor. So here you see 2, 1 and here we have a 3. Now we are assuming the current flowing through this 3 ohm resistor be I2 dash. So here current through 3 ohm, that is I2 dash, is nothing but what is the total current? It is I2 into what is the resistor which is opposite to this I2 dash. Opposite resistance is 1 ohm and divided by the total resistance here is 1 plus 3. Right. So I2 dash is equal to I2 into 1 by 1 plus 3, that is 1 by 4. Now what is V1? V1 is nothing but, okay, the voltage drop across this 3 ohm resistance. So voltage drop across this 3 ohm resistance is nothing but current flowing through this 3 ohm resistance multiplied by 3. Can you understand? Because V is equal to I into R. Here the value of current is I2 dash. What is the value of R? It is 3. Now we have calculated the value of I2 dash as I2 into 1 by 4. So V1 is nothing but I2 dash into, that is V1. You see here in the original circuit, this is our original circuit diagram. Just to find the value of I2 dash, I had just simplified the circuit like this. Right, once you have calculated the value of I2 dash, this is not the right thing. Once you calculated the value of I2 dash, you see again the circuit is splitted. Okay, original circuit is drawn. So this is your I2 dash and this is your 1 and 2 ohm. So now what is V1? That is V1 is nothing but the voltage drop across this 1 ohm resistor. Okay, we have to always consider the original circuit. Just to find the value of I2 dash, I had simplified. Okay, just unknowingly I had thought that is just from this diagram I had told you that V1 is equal to I2 dash into 3, but that is not the case. We have to find V1 only from the original circuit. Just to find I2 dash I had drawn this, right? So now what is V1? V1 is nothing but, you see, because these two resistors are connected in series, therefore this I2 dash flows through this 2 ohm as well as through this 1 ohm. So here V1 is nothing but it is I2 dash into 1, because current flowing through this one is the same I2 dash. So what is I2 dash? I2 dash is nothing but I2 into 1 by 4. So just substitute the value. In the place of I2 dash, it is I2 into 1 by 4. So again, what is the value of I2? We have just now calculated, right? I2 is, so what is I2? From this equation, I2 is nothing but 4 by 11 into V2. So just substitute the values, 4 by 11 into V2 into 1 by 4. So here we end up with 1 by 11. That is the ratio of V1 by V2 is 1 by 11. Finally, we have calculated all the 4 parameters. That's all. If you have any doubt, let me know in the comment section. Thank you.